Hello, everybody. This is Tony Miracker, and I'm the section chair here in Toronto. Um, just wanted to welcome you to our first virtual meeting that we've had due to the social gathering and the COVID-19 situation. But I think we're going to have a good presentation tonight with 4 presenters. I do want to reach out and thank Roberta Gorman from SMPTE Home Office for allowing us to use the GoToMeeting account. And also would like to thank the Toronto TTC for sponsoring this particular event. We've canceled the 2020 because of the situation that we're in. But you know what? We're looking forward to the 2021. 2020 really had a nice ring to it, but 2021 will be just as good. So I'm going to be at the controls here and start moving things around. Do apologize ahead of time if we run rocky here for a moment, but we just realized this morning that GoToMeeting decided to, or Home Office, I'm not sure which one, decided to upgrade, and all of the control panels and the buttons where they were before are no longer where we thought they were. So you know what? We're gonna wing this one, and I think we'll be okay. So tonight we're going to hear from 4 presenters, both Craig Yasman and Jordan Sweden are going to help out. They are going to man the chat room. And if you have a question, which we're going to hold off until the end of all the presentations, just type in the chat that you have a question. And then accordingly, either Craig or Jordan will announce your name, unmute your mic, and then you can present your own question. If you have no microphone access to this meeting, then do type your your question into the chat box, and one of them will read out your question. So without further rambling on my behalf, I'm going to hand it over to Craig, and he's going to introduce you to our first presenter. Craig, can you take it away?
Hi, Tony.
Yes, sir.
All right, you can see me. Great. Can you see me?
Yep. We can.
Great. Okay. So our first presenter is Anthony Kazoo. So just a quick bio on Anthony. Anthony grew up in CF, QC, TV in Saskatchewan. He played with Wardbeck mixing consoles and an off-air production control room. After 15 years of owning studios, recording bands, refurbishing consoles, he moved to Toronto, where he continued to rebuild and refurbish consoles, including several Wardbeck models over the years. In 2016, he earned an honors diploma in communication engineering from Seneca in Toronto. And then shortly after graduating, took a position at Wardbeck Systems as an IP audio product manager. He's the current chair of the AES here in Toronto. And in 2019, he took a role at CBC as a senior system designer, where he currently is. So Anthony's presentation is going to be on his homebrewed measurement system and all the fun gadgets in his garage. So I think I'm done. I can hand it over to Tony. And then Tony, do you want to hand it to Anthony?
Anthony's already got it.
All right, perfect.
All right, do I already have it? Hello, everyone. Welcome to the future. I have to say, thank you, Craig, for having me. Craig and I work together at the Canadian Broadcasting Corporation, and I come in every day and we talk about gadgets, and Craig and I are big-time gadgets, and I borrowed a gadget today, so I borrowed one of them Steadicam things, And I really don't know what I'm doing, but I was able in OBS to set up an IP camera. So I'm going to take you on a bit of a tour of some of the craziness of what I get up to, and I'll talk a little bit about it. What I have in my garage is a mixing console repair system of some sorts. And on the other side of the wall is a full-blown metal shop. So I have a lathe for turning metal, and the gadgets that come with this thing are just a spectacular addiction to go down, and a fantastic rabbit hole to actually get through. I do metal engraving, so I have a Pantamill engraver to make, you know, the vintage little buttons. And my most recent gadget is this Bridgeport milling machine that gave me the ability to do some serious milling. And one of the things was when I was setting up in the garage here, I had my good old-fashioned Wardbeck Systems mixing console that I needed to actually turn into a test bench. And I went through several iterations, and I'm going to tell you a little bit about where this all began, and how it's now led me into some very different things for my current employ, and for the future of what audio could be. Here in college, I was exposed to having multiple tests running simultaneously, and I was always obsessed with running multiple tests simultaneously. So when I graduated, I said, is there a way to test this stuff a little faster? How can I test a mixing console faster? So I started reading, and you get into the vintage Hewlett-Packard manuals, and you see, guy like this with a computer, and he's doing automated instrument measurements. And with these automated instrument measurements, you could talk to oscilloscopes and talk to spectrum analyzers and things like that. So when I wanted to do a mixing console under test, it wasn't just one channel of audio, it wasn't two channels of audio. So I wanted 36 inputs, 36 outputs simultaneously. And I said, well, there's got to be a better way to actually do this. And there's got to be a better system to be able to transfer this. So as you dig in, you find these beasts of broadcast. Well, it's a laboratory grade instrumentation that can connect from your signal generator to your pulse generator, and you can route all of these things from one thing to another. So, you know, now is the time to go on eBay, and you go on eBay and you find yourself a big HP 3235. It's the only 8RU piece of gear I own, and what I wanted to do was wire it with I'm a bit of a masochist, so I wanted to wire it with some kind of outputs, some type of direct outputs that were, easy to patch. So in the console, what I did was I wired up 24 in, 24 out, 12 in, 12 out per EDAC connection, and I had to tie that into the system. So I built all the EDAC snakes to accommodate any visiting mixing console into my system. So I could plug in TRS, I could plug in XLR, I could plug in DB25. It does not grind coffee, but I'll show you where I do that. With this console, this matrix system had 4 buses in the back, and I had to figure out a very creative way to use these 4 buses to measure this mixing console. So as you shut these relays, different things could be routed to different devices, and this channel could go here, and this channel could go to the device, and this channel could go to the device under test. So what I ended up having to do was, well, you got to lay it all out, and you got to engineer a solution of, well, it comes from the signal generator, and it goes to the device under test. And then I said to myself, well, I have to do it stereo, so I have to do a left and I have to do a right. So I created an Excel spreadsheet that essentially dictated where all these things needed to connect, and then I used that spreadsheet to generate where my EDACs would go, and then actually some of the software that was in the program itself that ran it. So the database that I was using to create the design was also being used to program it. When I started the workbench, it started as I got a couple pieces. I got a programmable power supply, and I got a programmable signal generator, and I got a programmable DMM multimeter, and then things got really boring with the patch bay and the ability to switch around and modify the patch bay and modify where the signal was actually going. So to automate that was really truly the object of what I was trying to accomplish. So my wife and I, we bought a house, and I took over the garage, and with the garage, the idea was the car was going to fit underneath this workbench. So the workbench was cantilevered over top of our car. So instead of the workbench being at the front of the garage, like most people's workbenches, mine was on top of the hood of the car. And it worked for a very long time, and it created this beautiful, setup for me that had this... I had all of my test equipment where I needed it to go, and the more I started programming, the more I started realizing that I didn't need physical access to these programmable devices. So my test system is a bunch of gadgets all put together. And with the COVID-19, well, I had time at home, and I decided to do some bench renovations. And I pulled all of the test equipment apart, and I decided to build a loft above my workbench. So I hid the oscilloscopes up there, I hid my audio precision up there, I hid my distortion generators up there, these are DC loads, so programmable DC loads, so you can test power supplies and power supplies that are under test, as well as spectrum analyzer. This is a wireless test set for CDMA test set. And then I also have over here power supply and a VNA. So I ripped out all the workbench. I literally took a saw and cut this piece out, and had to move a Wardbeck Systems mixing console from my, I guess I've had it for 10 years now, and it was in a studio I owned, and so I didn't want to keep it. I don't want to sell it, so I didn't want it in the way of my milling machine, so I flipped it on its side and lifted it up myself. I don't have any video of that. It was terrifying. This is definitely a 3-person lift, so next time I'm in quarantine, I'm going to try to have a couple helpers to help me with these big, huge loads. Once I put the console in, I got the console populated with a bunch of modules and a bunch of compressors, and now that I can bring those under test. One of the things I wanted was, in my new bench, I wanted a photo booth where I could, quickly just, drop a piece of equipment, take a picture of it, and away it goes. And with this mezzanine loft, I wanted a clever way to hide the equipment. So this fold out piece folds back. It does one of these, and it folds down, and then it folds back up. So when I'm servicing the equipment that's up in the mezzanine, I can actually step on this bench and actually put my weight on there and do some wiring. So it is a bit of a terrifying experience. So after I got everything hooked up, you have to re-address everything. Everything has an IP address. Everything has a bus address. So what this uses a very vintage technology called GPIB, and it is 8 parallel bits moving down one big, huge cable. So all of that had to be wired up. I had to redesign where all of these devices went. Here I have a vector network analyzer. This is a programmable power supply. So I can have 8 different unique voltages simultaneously. And then tucked away back here is that big, huge 8RU multiplexer that has balanced distribution as well as unbalanced coax distribution. So what I really wanted was a bit of a place where I could sit down and do some work and just have an empty canvas where I could just, grab an oscilloscope, grab some DMMs, grab some power. So this is where the power gets fed in, and then I could just put a device under test and away it goes. With the multiplexer, I had to fully load it because on eBay now you can buy, a multiplexer card for $75. What was once, $5,000 is now $75, but that's a common thing in the everything industry. So with this one, these are 8x4 coax multiplexers, and then so I have two 8x4 coax multiplexers, and then I have these wired as 36 channel multiplexers for the mixing console. So the mixing console actually plugs into these modules via a bunch of EDACs. And to wire it was, it's a nightmare because you have multiple ins, multiple outs, and every time you move a card, you have to reprogram everything because everything is hard-coded. So with these coax relay modules, what I'm able to do is put a balanced transformer, and then I end up with a 50 ohm. I end up with a 50 ohm line that gets switched all between these coax matrix. So I can route that signal to anywhere and from anywhere. Same with the power supplies. I can set those and program those to absolutely anything. Here are the DC loads. So if I have a power supply, what I can do is actually put this DC load onto a power supply and apply a programmable resistance in order to check that the power supply is actually capable of producing that power. I have two of them because a lot of the power supplies I deal with are bipolar, and you can do one side at a time, or you can do one side at a time, but if you do both sides simultaneously, it works substantially better. All of these devices use this GPIB language, which is a super old language, and it uses this connection management called Key Site Connection Expert, which is by Agilent. And what it does is it queries the bus, and it queries the bus, and it says, okay, well, you have this DMM and you have this power supply, and you can actually use it. So what I wrote was from scratch a piece of software that talked to the instrument. So every time I talked to the instrument, I would generate data, and every time I would listen to the instrument, I would receive data from the instrument. So I created a counter that went around and did a round robin, gather of all of the information, a poll of the information. With the power supplies, you apply power to it, and when you query the device, it reads what the voltage is currently being provided, and then it reads the current that is being pulled by that power supply. With the scopes and the DMMs, the exact same thing. So when I wanted to route the unbalanced 75 ohm stuff, I wanted to have a selector that, these were the sources and these were the destinations and these were the buses. So with any of these devices, you can go in to the bus and out to the bus and then probe it with a spectrum analyzer, or you can probe this bus with a distortion analyzer or an oscilloscope or two oscilloscopes, and you can have a whole variety of things. With the mixing console, what I was able to do was set up this. Well, I have two balanced buses because I have out to the device under test. So I would feed it the transformer, and I would feed it the transformer, or I could feed it the music. And all inside it's doing is just closing all of these relays to make these bus connections. So I would do, this is an EDAC. So this EDAC out, I could feed to multiples of these all at the same time. And then on the receive side of things, on the balanced bus, I could receive the balanced in, I could do the balanced buses, and then I could also do the monitoring. One of the projects I've been working on with CBC Radio Canada is the 600 megahertz RF spectrum transition. And where I've taken this GPIB programming is into my day-to-day work. So one of the tasks I was given was to analyze the current behavior of a whole bunch of wireless microphones. And by a whole bunch, we have over 200 frequencies to monitor in the building at any given time. So one of the pieces of software I wrote was this is a CSV like a table importer. And what it did was it imported all of the known frequencies, the frequencies I cared about, and presented them their frequency that I actually was looking at, and then also a bandwidth. And what it would do is it would go to my spectrum analyzer, which was on a TCP/IP network. So if I had a VPN connection to my spectrum analyzer, I would log into it, and it would do a round robin of all of the frequencies I care about and generate a report. And the things that I cared about, what it would do was it would allow me to do a, one span of this measurement, and then I would grab a zoomed out version just to see if there was anything nearby, if there were any new neighbors that were encroaching on that wireless microphone frequency. And then I would zoom in, and then I would zoom in even more, and just by changing the span values. So one of the things I have here is I have the software here running, and I want to show you some of the code and some of the complexities of building such a huge piece of software. So the next time you say software should be free, just do yourself a favor and design a piece of software from scratch, and then you will never ever say that software should be free ever again. This is 8 channels of spectrum analyzer, 8 channels of digital multimeter, and 8 channels of power supply. And then over here is a signal generator. So this signal generator is just a tone generator that generates a bunch of frequencies that I, as an audio technician, care about. And then also I have, let's see if I can expand this. I don't know. And then I also have oscilloscopes. So each one of these elements is a gadget inside the piece of software. So every time any one of these things needs to connect, each one of these has to have its own custom piece of software that goes with it. So for example, here's the bench router, and I'm just going to do a small dive into this, and I hope you can read the text that's on my screen. I'll go a little bit. So when you have crosspoint buses, you have to have flags saying that bus has actually been closed, and you have to have a visibility of where all of these things. So when you set up a router, what it does is it actually takes an IP address, it takes a GPIB address, and it generates a connection to the GPIB. And when you make this connection, you're also creating a CSV of all of the commands that it receives. And then I'm also creating a session description protocol. So within all of, sorry, I should do this off screen. So within all of those devices, I actually create a session description protocol that goes and actually defines what type of commands that it's actually receiving. I'm gonna see if I can load that up. My apologies. So you make the connection to the router. You push a button, and every button requires some type of programmation. So here I'm using flags. The color is the flag, and I'm crossing crosspoint latches, and I'm making these manual crosspoint connections, because in this case there were very, very, very few connections that I actually had to deal with. And one of the things that I found was, it's like the hottest topic in broadcasting right now is how do you make these crosspoint measurements, and how do you make these crosspoints, and how do you make these connections? So one of the things that I've been working on is trying to actually get a session description protocol to actually use these to connect. So here I have created a session description protocol. So every time a new device is created, I use a session description protocol file that takes of course it's in the other monitor, maximize, and then maximize, come on, move. Let's see. This is the thing about the Microsoft Surface. It's There you go. So what it does is it actually creates a session called bench mux. It gives me a time of day that it connects. It doesn't have a clock domain because I'm not, synchronized to anything yet. It actually gives me the indication of what the TCP GPIB connection actually is, and then gives me where I'm starting to keep the AES70 parameters of the device. So I can keep any of these AES70 parameters within the device. So all of these data types are predefined AES70 parameters that I am starting to incorporate into the software. As connections are made and connections are followed, everything is logged in CSVs. So I can create just an endless data pool of connections and things that come to the device. All of my spectrum analyzer, so when I do a full spectrum sweep, it saves that as a CSV and puts it aside. Being able to do this has really, it's sped up the workflow. It's sped up how all of these devices connect to one another, because I found that the hardest part about having a spectrum analyzer is being able to program it with some type with a quickness. And a lot of operators they wanted a read-only current status of the air and of what's actually happening in the building. So with these GPIB commands and with these GPIB type of queries and all of these instruments, what I've been able to do is automate all of these tests. So to give you an idea, to test this mixing console and go between every channel and generate a report takes 6 minutes now. And what used to be 5 hours of patching and going back and forth is really revolutionized in a very, very simple in a very, very simple type of automation test. And I'm sorry that the resolution is very poor on the screen. I moved quick, and it's all dependent on the signal. Does your wife understand what you're doing in the garage? Yeah, she most certainly does understand what I do in the garage. I don't think she may not understand some of the tests and the complexity of the tests, but some of the people in the Audio Engineering Society do not actually understand some of the tests that I get at. How much do you think I've spent on the gear? I have probably spent maybe close to less than an Audio Precision alone. So if I was I kind of capped it off at, if I was going to buy a piece of gear, I would buy an Audio Precision brand new, and that was kind of my cap. But the thing about it is, when you get into some of these store-bought solutions, it's I didn't have the flexibility that I wanted and the complexity that I was really looking for. So I had to make things overly complicated for myself. For me, it was the switching and the automating of the patching. And right now, every day at work, we're dealing with different vendors and they speak different languages and they speak different things. And right now, as my involvement with the AMWA NMOS IS-08 is starting to ramp up, we are now currently looking at event and tally information. And one of the proposals that I've put into the organization is that these type of Skippy commands, these very, very simple commands that talk to these devices, are very common to a lot of ways that people actually do, actually say commands. And what these things are really doing is it just says close and then a port number. And, it takes a tree of commands very similar to an SNMP tree, and it exposes it. And very much in the same way as SNMP, what you're doing is you're actually, you do a get and you do a set. And that is how 90% of these control programs operate. And they, there are all of these commonalities between all of these control protocols. So what I'm attempting to do is bring some type of clarity to do this. Somebody says the AI analysis. Well, what good is AI analysis if the data isn't structured similarly? Or what if what good is AI if you can't actually access any of the data? Yes, I have considered doing some AI, but I actually prefer human intelligence. And once the data is there, that's where the AI and machine learning, that's where the machine learning really comes into play, is to actually take these huge data sets of, 10 hours of recording a mixing console at 32 channels, and way to go. Yes, you could most certainly use an MQTT to map the data to a common data model, but MQTT is not a data model. It is a telemetry trunking protocol. So it is a great thing for publishing and subscribing. Yes. So one thing I could do is I could take all of these events and publish them to someplace else. And there is very much an application for MQTT. SDPs following MOS formats. Well, actually, they conform to RFC 4566. So RFC 4566 actually dictates how the SDPs are actually working. But I ran into a couple logical holes, such as, well, if I have an oscilloscope, is the probe the thing that needs the SDP? Or if I have a pair of DMMs, well, the DMM isn't the source, it's actually the measurement instrument. So I actually use the probe information as the source, and then I describe that, and then a oscilloscope subscribes to a source, which is one of those things. It gets complicated, and for me, all of this stuff is prototype software that I've built throughout my time working for fun from school. When I learned about that you could actually go into an instrument and see what was actually happening, it kind of blew my mind. And a lot of this stuff is, I saw Gord Langdon, Tektronix. They pioneered this stuff. This stuff existed in a lot of the video equipment that you probably have access to, and finally we are now starting to see. That. Question is, analysis apparatus noise floor is close to audio precision. Yes, it is. You got to remember, this is all Agilent Keysight equipment. So a lot of it comes down to how you wire it. And my involvement with the Audio Engineering Society goes deeper. I am actually the chair of the Standards Committee for Grounding and EMC Protection. So some of this is also parts of my experiments. So having total control of how the ground bus actually works is a big deal. A lot of this stuff is twisted pair, right? So everything on some of these vintage consoles, like the ones that I work on specifically, are balanced everywhere in every capacity. So the signal floor ratio is identical to the audio precision. But I also have an audio precision system 2 Cascade. So it adds to. What am I using for the web presentation? I am using OBS. And it is a fantastic piece of software. And I'm very sorry that the broadcast industry is going to be replaced by an open broadcast software. So and my gadget, I would say it is a bit of OVS. It is a bit of everything, and with that, I think that's my time. If you have any other questions, I'm going to hang around for a little bit. Great presentation. IP ownership of the software. I could give it away. So if you want to send me an email, my email address is, my personal email address is i@like.audio. So i@like.audio. So I like audio. Thank you very much, Craig, for having me. And CBC has not licensed this from me, but if they need it for anything, it's part of my job and my career and passion and hobby. So it's really easy to go. So thanks, Craig.
Yeah, thanks, Anthony. I can tell you're really passionate about this stuff. Great presentation.
Thank you.
All right, I think we're going to hand off. So our next presenter is.
I just moved it over to Luke.
Sure.
Craig.
Thanks, Tony. Our next presenter is Luke Sackerator. Here's a quick bio on Luke. So Luke is an out-of-the-box thinker, coder, urban explorer, and Japanese sake connoisseur. He's going to be giving his presentation tonight on Nagios, which is a broadcast monitoring program. And I'm going to hand it over to Luke.
I'm going to make one small correction there. It's a monitoring system for basically anything. Mainly, it's in IT environments. So first of all, I've went down this journey of trying to have a system that we wanted to monitor, and just looking what was out there, we had some cost constraints, and we evaluated a few options, and we settled based upon our criteria. We settled with Nagios. So what did we need? We needed something that was flexible, understandable, interoperable, so that we could get confident and be confident in our system. So why do we need it? We needed to prevent downtime, reduce troubleshooting time, protect revenue, have cold, impartial data, and plan for the future. So there's some capacity planning that we're able to do because we have the data. So in a facility, we have things that we built on. We have obviously we need to look at temperature. We need to look at power. We need to look at temperature. We need to fans on our equipment, make sure they're good, make sure we have a network, make sure the health of our drives, we have enough RAM, our OS is behaving correctly, and that our business applications are responding. So basically, Nagios breaks down into as our foundation. Nagios, the triangle, we have a host. This host has services associated, and those services are linked to commands, and then it's templated out so that the address is based from the host definition. So really, this is the most basic fundamental thing that you can monitor. Basically, we have host, we have a service checking it, pinging it, and we have the script actually running it. This is why calling it the triangle kind of doesn't work, but it's close enough. So we have our host, we have our services, so there's many things that we're checking on, and we have different ways that we present that data. And we have great graphs that we can use to analyze. So this is the size of the system we have right now. We have quite a few hosts that we're looking after. We're looking after, as we add stuff, we're going to get over 1,000, and we have a lot of services going out, checking, making sure that everything's okay. And there's a lot of different things that we're checking. This helps with a lot of the more things that you're checking, the faster that you can fix them and make your life easier because they don't have a chance to snowball. So Nagios allows us to even get more granular. We wanted to make sure that we were looking at what's important. So we have the ability to build hierarchies that allow us to look at and say, well, our host is down, be it a playout server or whatever. Is that important, or is it more important that the switch is down? Or maybe you're monitoring some hardware encoder, and that encoder then is going to a muxer. Your muxer and your in the realm of ASI, your encoder is more important than your muxer. And then the other thing is, maybe you're in a situation using this tool called business process integrity, that you say, well, you know what, having something, if we're in a cluster environment, go down isn't really a big deal as long as not too many of them go down For example, if we're still 80 or 90% up, we're great. So what we were looking for, and we had some interesting requirements that we needed something that was really flexible in choosing the product. As broadcasters look after a lot of gear that, you know, it's probably pretty hard to find. As it moves more towards IT, you have this kind of problem of you want something that does as much as you can, although everything's slowly moving IT. You're trying to get as flexible as a product that you can do. So we also needed to look at more of the conventional things that, you know, usually a data center, usually that in your typical IT data center would require. And continuing on, the biggest one really was, you know, we needed a way that we could really flexibly and easily look at SMPTE traps and SMPTE poles in a way that wasn't locked down. A lot of products seem to lock you down on there. We also have a lot of unique APIs, and we wanted to, you know, we wanted to be able to talk to basically any API and pull out any information that was relevant to having confidence that the system is working healthy. So we have a lot of problem areas, and how do we make sure everything's level? Well, Nagios has a rich set of built-in plugins. They're getting more all the time, and these are ones. Actually, I should be even clarify more here. These are plugins that support a wizard. So that's an important distinction between, as some of you may or may not know, who are more in the IT sphere. Nagios Core is a product that's been around for a long time. Nagios XI is built upon that technology and added some more user-friendly functionality to it. And with the traditional plugins, it's a script, whereas this breaks it into a more friendly user interface. So that's just continued. So the other advantage is that there's a really large community of, now most of these aren't nice, as friendly wizards, but they still are a lot of really great scripts that people have wrote and shared. And I just want to, this is just showing how simple really a Nagios plugin could be. Basically, we have some file that we have locally. We need that file to exist for whatever reason. And basically, if it exists, this check is good. If it doesn't exist, well, that's a critical failure. But obviously, the things can get more complex. You can use a wide variety of scripting languages. Pretty much anything that the system can run can be utilized for as well. You can compile apps as long as you stick to the plugin architecture. So one of the things that was really interesting that we learned as we started doing that was Nagios has a lot of things for just simply watching a folder, a watch folder. But really, there was the problem of basically you either were watching how old the files were, or if there was too many. And while those are important, I wanted something that looked a little bit more at what was actually happening, because having an old file there isn't so bad as long as files are moving, and having too many isn't as bad as long as some are moving. But we can also put in some thresholds. So I wrote a plugin for that functionality. And basically, this gets populated into the data format where we present as graphs. So the other thing is flexibility was really important to us. And luckily for us, we had some gear that acted as an SNMP to contact closure interface. We had 50 of them, and we were able to reuse them for various surprising installations. We had some servers where there was only data that we were able to get out of effectively through GPI, and things like reference lock, and there was and input, valid input. We were able to actually use this to actually link into Nagios, and we just wrote some plugins. And the other case is, well, maybe you have third-party hardware in your chain that you need to make sure it's working because you have some type of agreement for this, but you don't have control over the actual device itself. So by leveraging the ability to just look at some simple contact closures and at least giving yourself the ability to say, well, we have some degree of certainty that this hardware is working as expected. So the other thing too is that is hard to find in a system out of the box is sometimes you sometimes you have no other option. It's just such a black box that you need to scrape a web interface, whether it be the device's age, which just doesn't support the protocols you need, or it wasn't designed like this. Emergency alerting is very important, that we make sure and we have confidence that it's working properly all the time. So the simplest solution was basically that we parse, and within the interface, it presents the are we connected to the data poles. So we check that both data poles are connected, and there's a little bit more logic and other checks that are part of this that we'll get into in a later slide. So how far can we really go with this? There is an open source project that I've been working on where you have an older piece of technology that really doesn't even have any network connection that you want to check and make sure it's working. You could put a photoresistor on there, and there is a project that takes and basically you can compile SNMP right on a very low cost Arduino with a network shield. And as well, there's because LTC I don't see going away very soon. I mean, it's still a very strong part of a facility. There is as well a project where, and it's quite simple to do, to take the LTC, add a little bit of logic to make sure that your time code is continuous, and basically you can send some traps into Nagios to handle that. Just make sure that all of your far off corners of your facility are receiving valid time code. As well, now getting on to another idea where you can leverage another low-cost unit for monitoring systems. You can take the FFmpeg project, and you can use the FF probe, and you can, if your ASI is traveling over IP, you can basically probe that periodically to make sure that you have your stream throughout your network, and as well to make sure that your backup stream is also working and it's where it's expected to be. So once we've found once we found things that are wrong, we need to notify people to fix them and find some ways to communicate that. So Nagios has some really interesting some great ways itself, but I wanted to take that, and I needed the flexibility to take that to a little bit further of a step. So here's just a basic splash screen. They have another nicer one that you can use that you can put up on a monitor, but that still wasn't quite what I wanted. I wanted to go a little step further. And what the solution that I came up with was we were having some issues with one of our graphics boxes, and it was hard to see because it would pass video and not really give any real indication that there was a problem. So it was very time consuming for master to identify. So with some basic logic you could look at, and using the business process integrity, you could leverage that, and you could make sure, hey, is everything that we need working? And if it's working great, we're going to take that, we're going to put it to a vNode, and then we're going to take that, which is a SNMP to contact closure gateway, and we can then put an indicator on a monitor wall saying, hey, I need some attention. So something needs to happen. This helps, protect revenue as graphics and lower thirds are important. So we just want to make sure that we look out for that. Another very important thing is to make sure that, as I referenced before, is to make sure that our emergency alerting will always be available when an alert is triggered, and we need to make sure that that alert goes out, because that's very important. In some cases, sadly, the difference between life and death for some folks. So basically, to make sure that we're always doing we're always ready to go, we check the unit's health, but we also make sure that we can see the data sources. In this case, the system's designed with redundancy, so using the process logic, we're able to see that we want to make sure that it's not a problem if one of our data sources goes down. And so using the kind of the clustering support, we only need 50% of our 50% up is fine. So we will still get that data. How far can you go? Well, I've been working on a project which basically to take Nagios alerts using an open source library with Linux to convert the alert text to a WAV file. Unfortunately, that WAV file isn't quite groomed enough, so we need FFmpeg to groom that WAV file, and a simple Python script will basically execute a phone number as well as play out that WAV file, so that in instances where it's required, we can get alert. Yes, there is other ways to do this where you can go upon some service, but that has the downside of that is that service has a monthly cost. So this is where we get into some really fun stuff that where you can really help troubleshooting problems with the system in a nice graphical way. This right here is our KVM network, and it makes sure that our system is working properly. And basically, in a really quick and easy way, you can identify where any issue is. As well, we also do the same for with each row of gear where there might be a hardware problem that needs to be addressed. So some last remarks, and if I have time left, which I believe I do, a few minutes anyway. One of the things that we found, it's a little surprising sometimes, which you may come across things that you thought were power was supplied from one source. It turns out not to be the case. Sometimes you find out, hey, I didn't realize that this device over here reboots a lot more than I think it does. We need to figure out why that's happening. Sometimes you find out, well, your MAM system works really well most of the time, but every once in a while it hiccups, and you have to address some issue that maybe space is filling up, and if you don't address that issue, it will become full. So let me see. Okay. So yeah, here's just some more of the wizards. The wizards are really great because you just go, and if you want to pull a device, here you go. It's really user friendly and intuitive. Here is the very large collection of software that people have wrote that can be utilized. There's a lot of stuff that most of it's more geared towards the IP sphere, but I myself have made a large amount of custom plugins for just different things that couldn't be handled the routine way. A lot of stuff interacting with APIs that you're just not going to see plugins for, and it was really important for us to make sure that that's working. Because our software tends to be a little more niche, so okay. All right, so I'm going to hand it back over to Craig.
Thanks, Luke.
Yeah, thanks, Luke. I'm just waiting for my camera to come back up.
Francois, I'm moving presentation over to you.
All right, so I'm just going to start with, so thanks, Luke, for that presentation. I'm going to start with a quick bio of Francois. So Francois Legrand has been with CBC since 2004. He joined the corporation as a designer of broadcast systems and became an electrical engineer in 2005. From 2011 to 2016, he held the position of a senior project manager, where he played a major role in the transition of all national news shows to an automated production. In 2015, Francois became the senior system director of core systems, where he manages all teams and all capital budgets related to CBC core infrastructure. And he's currently knee-deep in the new Radio Canada building in Montreal. His presentation is his third attempt at building a S2110 compatible Christmas tree. All right, I'll hand it over to you, Francois.
Francois, you're still muted.
Sorry about that. So thanks.
We can hear you now.
Okay, perfect. And you see my screen too? I guess so. So
yes, I see your screen.
Perfect. So those that know me a little bit knows that sometimes I'm talking about my SMPTE 2110 Christmas tree, and nobody really saw it before tonight, except for very few people. So yeah, so here's the story. So it all began in 2017. My wife gave me a challenge to build a plywood Christmas tree. I really like to do woodworking, and she came with that project one night. And I said, well, that's cool, but it's too easy. So it needs some electronic, and it's a good excuse to teach the kids about electronics. So this is how it all started. So the first step was to find a cheap and easy way to display colors, just like pixels in a screen. So I went online and I found that you can buy for really cheap, about 25 cents each, RGB LED. And those LED, they have a built-in RGB controller that works with 24 bits. And they can be daisy chain one LED after the other one to create a pixel stream or pretty much a line of video. And when you look at the protocol, it's a very simple one-wire protocol. And it's blue, green, and red data from the very last LED to the very first LED, and you just send them over that one-wire protocol. So when I looked into that one-wire protocol, I said, well, that's pretty close to RFC 4175. So I changed a little bit the project. So why not make it an RFC 4175 Christmas tree? And RFC 4175 is pretty much what became, I don't want to say it became 2110, but the 2110 standard relies heavily on that RFC, and that defines how to packetize uncompressed video to be able to carry that using an IP network or RTP stream. So I changed a little bit the project. And when you look at the RFC 4175, it's a very simplified description of the protocol, but you get an IP header, UDP header, RTP header, and then you have a sequence number that complements the RTP sequence number. So that's just a number that increment packet after packet. Then you have a length field, and in my case, it's the number of LED in the Christmas tree times 3. Then it's progressive video. It says the resolution, so it starts at line 21. Then every line fits within one packet of data, so that bit is 0. Then there's no offset, and I just have to pretty much inverse the data that I fed to the LED. So RFC 4175 in that project was the input. I just had to strip out all the headers and reverse the data and boom, feed it to the LED. So that was the original intention. At that part of the process, it was not built yet. So now I had LED. I also needed a brain for this project. So there's many ways to do small project at home. Luke just showed us Raspberry Pi and Arduino. So those were pretty much the 2 platforms I experimented with to begin. RFC 4175 can easily be handled by a Raspberry Pi. But the one-wire protocol that's needed to feed the LED, it's very tricky because a Raspberry Pi, it's not a real-time device. It gets interrupted all the time. And to try to emulate that one-wire interface, I didn't have success. I'm not saying that the LED were not lighting, but they were not reliable. So then I look at Arduino. Arduino, it's very easy to do one-wire protocol. It's very accurate on the timing side, but it doesn't have Ethernet natively. So it cannot do RFC 4175. And I didn't want to combine both at the same project. So I kept looking. And this is where I found the Beaglebone Black, which is a very interesting single board computer. It uses an ARM Cortex-A8 core as a processor with ARM core. Sizable amount of RAM, and the eMMC is big enough for everything. The Ethernet is good. But the interesting about that device, which is very comparable to a Raspberry Pi, is that the device internally, they have two core, which are actually 32-bit microcontrollers running at 200 meg that you have the full control over, and you can do whatever you want with them. And they share the same RAM as the main ARM core. So it's very easy to exchange data between the main processor and those two microcontrollers. It runs Debian Linux, and most of the Raspberry Pi software can be compiled and work on that platform. And it costs around $95, so it's not too expensive. So on the software side, it was very easy to accomplish this project. Receive RFC 4175 data by Ethernet or Wi-Fi. The LED works not with RGB data, but it's blue, green, and red. So, but that's perfectly allowed in the RFC. So that's how I received data. I had to do a very simple RFC 4175 to a protocol that's called Open Pixel Control protocol. And that was a simple Python script that was stripping the header, inverting the data, adding a little bit more overhead on top of it. And I was streaming that data to a piece of software that I was able to use as is, which is called Ledscape. And then Ledscape writes pixel data into the DDR. And then I had to build a very simple driver in assembly to drive those APA 106 LED from the PRU. Use a simple level shifter, and then I was able to drive the strings of pixel. And to be honest, that works tremendously. It worked very, very well, very reliable. You can literally drive hundreds of meters of LED using that infrastructure architecture, and it was very good. So this is how the project looks. So that's the base of the Christmas tree. You can see the Beaglebone, small PCB I made to distribute power and data using a homemade wiring harness, two homemade PCBs that were actually the branches of the tree. So this is the internal of the Christmas tree under test. So you can see that the LED here are not lit. And then I was able to run various tests signal to make sure that the whole thing was working. So if you remember, one of my interests in that project was to teach my kids how to do electronic. They were quite young at the time, so they were not really interested by the electronic part of it, but they really were with the mechanical assembly. So I used my kids to basically do the assembly of the Christmas tree. So here you can see that the thing starts to take form. Those are the branches, a little bit like the one my wife wanted me to build at the beginning in plywood internally, and then you see the homemade PCB with the LED that go through the branches in wood. So this is the finalized version, and at the end you just close the base with the Christmas tree, add the beautiful star on top of it, and that was it. So I thought that case closed, project done, everybody is happy, and that's the end of the story. But that was in 2017. Then in 2018, the kids came back to me and said, that was cool what we did last year. Can we build one, each of us, and give it to our teacher as a Christmas gift? The problem is that I have 4 kids. The bill of material is around $300 each Christmas tree, more than 1K. So then I started to look at a cheaper way to build those Christmas trees. So 2018 version really starts as a cost-saving exercise. So the first thing I did was to replace the Beaglebone Black by another type of microprocessor that is way cheaper, which is the Espressif ESP8266. So that reduced quite significantly the bill of material because those boards are $3 each as opposed to $95 for the Beaglebone. Then I also looked at cheaper LED. So I switched from the APA 106 to the World Semiconductor 2812B LED. So from 25 cents each to 8 cents each. And there's a lot of LEDs, so that's a significant cost saving. Then I decided to make the Christmas tree naked. So, and that meant leave the birch plywood in the forest. No wood whatsoever, or almost no wood in that project. And then do what every manufacturers do when it goes to cheap electronic, cheap, affordable. You remove the built-in power supply, and then you pick your favorite power adapter to do it. So all of that together significantly reduced the bill of material. The next thing I did was to make it smaller, so way smaller. That's the 2017 version. And this is the 2018 version. So I went from 1.5 meter to about a feet, so 300 millimeter high. But it's the pretty much the same concept behind. The ESP8266 microcontroller processor or system on a board is a really interesting product. It's really affordable. It runs at up to 160 megahertz. It's a 32-bit processor, so you can do a lot of stuff with it. It doesn't have a lot of RAM, so for your actual data, you have 80 bytes of data. The version I had 4 megabytes of flash, so that's not too bad. You got built-in Wi-Fi. And when I finished the assembly, I figured out that it can almost reliably drive the RGB LED. That chip, it's one of the chip that powers pretty much every affordable IoT product you will find at Canadian Tire. As an example, those, I don't know if you still see me, I guess so, but those smart power outlets that I bought from Canadian Tire, they are using exactly that system on a chip internally. So very high volume, very cheap cost, so that's good. The PCB, which is the base of the Christmas tree, is very simple. On the back of it, there's a small development board. Then there's the rotary encoder to select the pattern. There's a potentiometer for brightness control. There's a DC barrel connector because the micro USB connector on the dev board itself cannot handle more than 1 amp, and that's not enough to power the Christmas tree. And there's a level shifter. So at the end, it's very simple. The assembly was a family project, like the whole thing. So there's a 50 PCB in the whole design. There's a tons of 100 mil header connector to solder between the branches and the hub, then between the hubs themselves, then from the hubs to the base, then from the hub to the star on top of it. So that's 316 pins altogether. Everything that was surface mount was soldered by my wife, by mommy. Everything that was through hole was soldered by the kids themselves. The final assembly was done by the kids, and the QC was done by me. And I think that the failure rate was pretty much 100%. So I had to rework most of the PCB, but at the end, it was a great learning exercise for everyone. So teaching programmation, especially to young kids, can be a bit challenging. My kids were already familiar with Lego Mindstorm and Scratch, which is a very good tool to teach programming to kids. But I wanted something that was a little bit closer to actual programming. So that little microprocessor, the ESP8266, can run something which is called MicroPython, and MicroPython is a very lean version of Python that is designed to run on microcontroller with constrained environment. It's not compiled, it is truly interpreted right from the microcontroller itself. And there's native libraries that can be used to drive those LEDs. And to display a rainbow over the 160 LED only takes, it's not even 7 lines of code, it's basically 6 lines of code. So if you download MicroPython, paste that in your main program, and you execute it, then you will see a rainbow over the LED. So for teaching, it is perfect. And there's plenty of built-in function to teach basic and not so basic video processing concepts. So that was very great for my kids to learn about video processing using that project. That was the good thing. The bad thing is that the native LED driver on the chip in MicroPython uses bit banging, which is subject to software interruption. And when that happens, it creates visible artifact that can be seen, especially when doing something else with the chip. As an example, if you are doing communication over Wi-Fi or serial interface, each time you will see disruption in your video animation that you're trying to create. The other thing is that the very limited amount of RAM, especially when used by an interpreted language such as MicroPython, it's not enough to allow complex animation, the web interface, and the REST API to run simultaneously and reliably. So that's the only time in my life I hope I will use that logo. But for me, it was, I had to stop trying to do 2110 on that $3 microcontroller because it was simply not powerful enough. So conclusion for the second attempt, I just disabled the web interface. That was enough to have reliable animation. We built 4 of them. We gave them to the kids' teacher. They were very, very happy. The kids learned cool electronics concepts, including electronic assembly basis. They learned how to do HSV to RGB color conversion. They learned basic color maps. And the project was named one of the best Christmas PCB project by Elektra. Elektra is the PCB factory I use to have my PCB. And if you were submitting your project, PCB were free. So I didn't even had to buy the PCB to build that project. So in 2019, the kids wants to turn those Christmas trees into a business. So they asked me, can we do more of them and try to sell them? So to try to be able to sell them, we had again to be serious about cost savings, because that small Christmas tree, when it's all assembled, still costs about $40 to build. So those were the objective for the third version. I wanted to address the issue of the 2018 version and really make it 2110 compatible this time. So the first thing we did, it was not a cost saving exercise. but it was basically to select a system on a chip that was more powerful. So we replaced the ESP8266 with another microcontroller from the same company. And this one is the ESP32. ESP32, it's a little bit more cost expensive. It's not $3, it's $3.20. But for that, you get dual core instead of a single core. So you can have one core handling the LED and another core handling the rest. API and the web interface, it runs at 240 megahertz. Same amount of flash, but 4 meg is plenty. Way more RAM, so that's good. It's really, really good for that kind of application. You get the same Wi-Fi built in, but you also have Bluetooth Low Energy 5.0. And but on the negative side, it's that's a module. It's not a development board. So you need to add your own USB interface. You need to add your own power management subsystem. You need to add also all the circuitry required to actually program the chip itself. But altogether, that's only $2. And yes, you get, I put it in red, and it comes directly from their data sheet, but you get a hardware PTP block that's fully compliant with PTP v2. All of that for $3.20. So, and those are Canadian dollar. They're not even US dollars. So that's pretty good. And you can see that the chip is also certified by Industrie Canada for the RF side. So it's good stuff for $3. So the other modification we did was to replace the mic, going with the small module. I lost the micro USB connector, and I decided to use USB-C instead of the DC barrel connector and the micro USB. The problem with USB-C is that the connector itself was never designed for hand soldering at home. A full USB-C connector has 24 pins. You can find 16 pins connectors, and those are basically restricted to USB 2 speed. They will never reach those 5 or 10 gigabits per second speed, but you don't need that for a project like those. And you can also find on the market 6 pins USB-C connector, but they don't have any data capability whatsoever. So I decided to go with the 16 pins. I know that there's people coming from manufacturers on the line today. So if some have very good idea on how to solder them easily by hand, I'm really interested, because basically the whole thing is solder using lead-free solder, but I was totally unable to solder them lead-free. I had to use lead alloy. Yeah, Anthony, toaster oven, you still need some kind of temperature regulation. I guess that's another project to build a toaster oven to do that. But yeah, that might be one idea. So the good thing is that with that connector, you can use any good quality USB power brick to power the Christmas tree, including the MacBook power adapters. So the other modification we did was to remove all except one header connector and replace them with castellated holes. It's cheaper, it's way sturdier, it's easier to align when you attach the branches into the hub, and it's a much quicker assembly. We also reduced the size of all the hardware. The initial idea was that less brass means lower cost, because the hardware after the LED is the second biggest cost source of cost on that project. but it turns out that it was cost neutral at the end. We also replaced the rotary encoders and the potentiometer with simple push button. Those are less than 5 cents each, so it's way cheaper. So this is another of my kids doing the soldering. So the good thing with surface mount, those kids they have tiny finger and they are really not that bad to do surface mount soldering. So now with that new version, they're a bit older. They were able to do it. Especially they are assembled using leadless paste alloy with a mask, so it's easy to apply the paste, and it's easy to solder them also at home. So schematic, it's pretty much identical to the 2018 version. It's pretty much the same type of component. There's a serial to USB converter that is used for the very first time you need to program the chip. And after that, it supports over-the-air upgrade. So I can do a full firmware upgrade over the air after the first bootloader is put inside of it. There's the simple regulator. There's a 2 transistor to put the chip in program mode. Again, the level shifter, the 2 push button, and that's pretty much it. It's a very simple circuit. So this is the finished hardware. I have one of them right here that you can see. And if I just connect it right now, it boots, and then you will see a few patterns, one after the other working. So I can say that this version so far, hardware is rock solid, animation are good. So so I think the third attempt will be the good one. So what about the software portion? It is the first thing I did was to reuse the code from the 2018 version in MicroPython. And although the ESP32 is way more powerful than the ESP8266, it still uses the same bit banging LED driver, and the performance is not good at all. It's way worse than it was on the ESP8266. So I guess that there's just too much stuff happening in that chip. It is bigger. There's more stuff that MicroPython run that you don't really know, and it was constantly disrupting the one-wire communication. There's a nice feature, however, on the ESP32. It's called the RMT block. And the RMT block, it's basically a hardened block designed to handle infrared communication, both receive and transmit. And infrared communication requires very tight timing. So I wrote my very own driver to drive the one-wire LED using the hardened RMT capability. But the problem is that in MicroPython, they gave you an API to access that block. But for each one of the bit you want to transmit, you need to specify the T0L or T0H. So basically, for a 0 bit, you need to maintain the data line at a low level for a specific period of time and at a high level for a specific period of time. And then for 1 bit, it's the same concept, but it's different period of time. So for every bit you want to transmit, you need to pass to their API 2 32 bits integers to define those timing. So the end result is that there's a 64x blow up in memory usage when using that module. So to transmit the data to drive a whole Christmas tree like this, with 160 LED. It requires 30.7 kilobytes of memory usage, which is a lot. So I have 5 times more RAM on that chip than I had on the previous version, but I need 64 times more for some tasks. So I'm back to the same memory issues as I had before. So that was last Christmas. So around Christmas of last year, this is where we were with the kids. So now entering 2020, it's just a software update, but it's software, like Anthony said, it's not that easy. So I decided to ditch MicroPython and go back to C++. The good thing is that the ESP chip can be programmed using Arduino IDE. It's much less kid-friendly than Python. This is the code required to display the same rainbow over 160 LEDs, but it's still not that bad. There's a very good open source library called FastLED that exists. It offers rock solid performance. This is the approach I'm currently taking to build a SMPTE 2110-31 compatible Christmas tree shape, not LED meter, but peak meter. Sorry about that. So this is the code I'm working with the kids as we speak, but it's not working well enough that I cannot show anything yet. At my last birthday, Anthony gave me for my birthday a Primo. So Anthony, the very first device I will use to test my peak meter will be your Primo. So I will tell you when it works. I hope it's gonna work. And after that, I want to add AMWA ISO 4, ISO 5, ISO 8 support. And I also want to write an Ansible playbook for automated deployment with the intent to open source everything, the PCB, the schematics, the code, so that people that really want to dig into 2110 and see how it works under the hood would be able to do it. So if you have any question, comments, complaints, if you want to try it at home and maybe have a few PCB, I don't want to make money by selling the PCB, but if you want a PCB kit, I guess for a beer or something like that, we can work something when I will be allowed to travel to Toronto. So unless we have some question, that's it for me. Anthony wants to see the mill. Okay, so this is the milling machine in my 56 square feet garage shop in town. It's really small. It's nothing compared to your shop, Anthony, but I just build smaller stuff and it works for me.
Mine is a single car garage, so I think it's about the same. So it's you have to take advantage of the vertical space. That's what I learned, is it's the vertical space that matters.
Yes, but when the ceiling is 6 feet
Low.
and a half. So yeah, any other question or no?
Yeah, I think we're leaving the questions till the end anyway. Thank
Okay,
you, Francois. That was a great for you sharing your project. I love the evolution of it. I love how involved your kids were. I can't get my kids to get out of bed these days, never mind solder Christmas trees. So that's pretty impressive. All right, so I think, okay, cool. I think our next presenter is Brian. Here's a quick bio on Brian. Brian is the National Brands and Project Technology Manager for VizTech, where he manages a huge stable of over 150 products of audio, lighting, photo, video, camera, and digital productions. Prior to VizTech, Brian enjoyed a successful career at Sony, where he had many roles, including acquisition marketing manager, systems responsible for a complete range of Sony professional products, including cameras and other peripherals. All right, Thank you, Brian. Do you?
Thank you. Okay, so the first thing, I just want to apologize for my audio because I'm actually using the built-in microphone, which is the absolute worst piece of audio that I have here in my office. I am working actually above my garage. So this is my bedroom that's above the garage. So I'm a little more elevated, I guess, than a couple of the other people. My talk is not, as many of you know, I'm not an engineer, so I'm a little bit more product focused. And so right now I'm sharing some stuff that I been discovering and some new products and whatnot, because what I thought is that in this day and age that so many people are needing to either use collaborative software or do live streaming and whatnot, that they might be interested in some of the tools and some of the things that can make that a little bit easier. So right now you're looking at my Logitech webcam that's connected to my PC, and that's because the built-in webcam is actually only a 720p. This is at least 1080. You can see that what the quality is like here. But the things that I like to talk about with live streaming and collaborative software is basically there's three really important things to think about when you're going to use those tools, and that's lighting, camera, and audio. So those are all things that you can do to beef up your system rather than using just the built-in audio and webcam that's built into your laptop. And this is a 17-inch laptop, so the webcam is actually a little bit higher than some of the other smaller 13-inch laptops, where the webcam tends to be looking up your nostrils and things like that. So the webcam position here is actually not too bad. But you can see that it's probably reasonably well exposed, and that's because I have a lot of lighting going on. But I'm just using OBS here, so I'm just gonna go back here in OBS and again switch to another source. So again, this is me in looking a little bit more normal than, with a haircut and everything. And yeah, so basically. Most of you know that I am really kind of an inspector gadget. That's really a big part of what my job is to travel around and find new gadgets and new products to add to our stable of goods, and basically take those to market in Canada. So a wide range of products and whatnot that we work with. So basically, what I'm doing here is I've got a setup here in my office of multiple different cameras. So one of the things I'm using is this ATEM switcher, and I'm switching between some of these sources. I don't normally use that webcam, and so this is the side shot that I have here, and then this is the tabletop shot of some of the products that I'm going to talk about tonight. So first off, I wanted to show sort of a battery product because everybody needs portable power and whatnot. And these products are actually somewhat unique in that the size of these batteries, I mean, these are standard V-mount type batteries that have a standard V-mount that can go on any broadcast type camera. This battery is actually a 50-watt version. It's called the Nano One. It's ultimately small. The really neat thing about this battery is that it has a number of USB connectors on the top of it. So it's got a USB-C connector, it's got a charging port, which is a micro USB, and it's got a standard size USB. And then it also has on the edge of the battery a D-tap as well. So now this battery can be used to basically recharge or power just about any device. You can use it to charge your phone. You could use it to run video transmitter or a follow focus or something on the camera, send off also the D-tap to something else while the battery's powering the camera. And the nice thing about that USB-C type connector that's on the top is that it is a full 20-volt connector. So that's actually powerful enough that it can drive a lot of the newer laptops that are out there. So this is the original Nano One, which is a 50-watt version. And then this version is slightly larger, slightly thicker, about twice as thick. So this small battery has the same power, 98 watts, as the standard 98-watt full-size V-mount battery. The other thing that's neat about this battery that I like is that there's actually a little built-in display, and that display actually shows you how charged the battery is, and also the voltage that it's outputting on either of the USB ports. So that's really good. And again, you can even recharge the battery with a standard cell phone charger. So if you lose your battery charge or whatever, again, you can hook it up just to that micro USB port and recharge it in the field. So great batteries just to have in your kit bag, drag around anywhere, because they can power up just about anything and be recharged easily just about anywhere. We do sell travel chargers and full-size V-mount battery chargers as well. This is a little adapter plate that can go with it, and this just changes or steps down the V-mount to a Sony NPFL type battery size. And there's two different versions of this adapter, one that'll take it down to the 7.2 volts so that it can go on any standard monitor or whatever, or a camera that takes that 7.2 volts, or one that just does a pass-through, a simple pass-through that does passes through the 14.4 that's coming off of the V-mount battery. The next thing I wanted to talk about, so again, there was the Nano 1 and the Nano 2 there, is basically this new light that's coming in June. This is called the Nanlite Pavo Tube. And this is actually a small LED type tube. It is fully bicolor. It's a standard T12 size tube. It's kind of made a little bit octagonal in shape so that it can sit at certain angles, and each end is also magnetic, and it also has 1/4-20s in each end of it, so you can put it on a stand or clip it on a mount or whatever on a 1/4-20 mount. That comes with a couple little pieces of metal so that you could tape those to a wall or whatever, and you can basically stick this light almost anywhere that you need light. But if you use a nice little stand that you can put this on, you can also use it as a light beside your webcasting system, and so it becomes a nice little desktop kind of light system that you can have sitting and have one on either side, so you can have a key and a fill light. So that's basically that one. Here's another very affordable little light. It's called Elektra. Again, you can see all the little LEDs in the front, and it has this little diffusion rubber that goes onto the front of it, can diffuse the light out. This is a full IP rated light that can go down to 30 meters submerged. There are two other lights in this family as well. There's a bicolor version, so it can do full bicolor. This is a daylight only version, the small one. The small one is also magnetic, so it's very cool. I use it for sometimes working on my car and stuff. I can stick it up to the hood of the car and whatnot, work on my car with it in my spare time. So again, just a neat little light to have with you if you're going to do set up anywhere and you're going to do a little bit of collaborative stuff, or just need a little extra light to fill in some anywhere that you need to. This is another light from Aperture. This Aperture light is called an MC, and MC standing for multicolor. So this is also a fully RGB, so it's a fully bicolor and also an RGB capable light. And sorry, I just have to hold it down for a second. And I can put it into different modes here of effects and things like that. So it can do all kinds of different color changes and effects and lightning and things like that can all be done with this light. So again, it's just a nice little portable light that you can use, again, sitting beside you for lighting yourself up when you're doing something collaborative on your computer, or just a nice little light to have in your kit bag that you can use anywhere. You either put in a splash of color or whatever your desire. So that's another little thing there. The next thing I want to talk about, because a lot of people are streaming with their phones, is basically this little wireless mic system that can connect right to your phone. So this is actually a receiver with a lightning jack connector on it that can go right into your phone. And so when it's connected, virtually any app that you're running on your phone, any video app or audio recording app, can now be connected. It's a 2.4 gig wireless Wi-Fi digital connection. And this little transmitter has both a built-in microphone and also comes with an optional lav that can transmit to this receiver, and that'll be picked up by whatever app you're using. So if you're doing live streaming of whatever, you've got a little home business or something, and you're using the camera in your phone to be able to generate those images, you can get some really good clean audio, and you can move around. So maybe somebody can follow you with a small handheld gimbal or something like that, and you can walk through the home. It'd be great for real estate people, those kinds of things in this day and age, wanting to see that kind of stuff. So that's that. So there is also another brother to this, which is more designed to go on to small cameras, compact SLRs and full-size SLRs. The receiver, actually, the little clip on the receiver, you can use it to clip on to either the hand grip or something, but it'll also fit right on the cold shoe of the device. While I'm talking about audio, Sony has recently updated their wireless, their UWP wireless systems. And so rather than inserting the batteries in the side, they now have made the transmitter more compact. And now you can insert the batteries back here into this little adapter, and this just clips onto the front of it. And they make both a single receiver and a dual receiver pack that can work with that. And again, it's this is digital wireless as well. So the signal is being sent digitally. And one of the other things that they've done now is they have a new connector that can connect to certain production cameras, like their new FX9 and things like that, that can actually pass through the digital audio in a direct connection from the wireless receiver directly into the camera. So that bypasses a full P to A cycle. So you don't have to go from back to analog and then in through the XLR ports and then back to digital resampling. Couple other things that you can kind of see around here. I got one right here, is the Rode Pod mic. This is a really nice, super affordable microphone, but it's a very large diaphragm microphone, so it's ideal for home podcasting and webcasting type applications. And because it's got that very large diaphragm in it, and basically kind of a built-in spit guard as well with this with the grid there on the front of the microphone, it has that real ballsy kind of DJ voiceover or sound. So nice, very nice microphone. And they also make another microphone as well that's called an NT-USB microphone. Again, very affordable desktop type microphone, comes with a stand, and it can plug directly into your computer via the USB jack, and so no other wiring is required. So again, nice for doing collaborative and live streaming type of work. The pod mic is an XLR mic, so you would need some kind of interface or something. I have this little mixer here that I just bring in the XLR, and then it has USB that brings it in, a little Behringer mixer. So actually, before I get to this next slide here, just going to talk about this for a second. So again, if you were running traditional switchers or whatever to go into a live streaming system, most of the switchers would be either SDI or HDMI capable switchers on the back, so it would have all those types of connectors on the back. So you need some type of interface or capture card. So I got a couple here that are basically just HDMI. This is a cheap Elgato version, and there's a couple of different versions from Blackmagic. This one does full AV as well, so if you have old stuff that you need to capture or whatever. And then this one is actually can connect. It's got the older type DisplayPort or the original Lightning 1 and 2 jack, and that can connect to my older Mac here that I'm using to present from. So all of that stuff is also great stuff for streaming. And so now what I'm actually using here today to stream with, and what I'm cutting with all these different sources, is because I'm a very tactile person, and so I like to actually punch between these different sources. is I have this little A10 Mini. And so I have the original A10 Mini, and again, it's got 4 inputs on it, HDMI inputs, and then has the capability to connect via USB directly to your computer. So you don't need any of those separate outboard capture cards or interface cards. This does the whole job for you and can easily allow you to quickly select any of these sources. And so here I'm connected here now. I'm using a Blackmagic, a pocket cinema camera with a nice cinema lens on it. So you can see that it's got the nicer shallower depth of field and whatnot. Things are kind of out of focus behind me. Looks a little bit nicer. And with the Pro model of the A10 Mini, it actually gives you full control of the camera. And so you can actually have full tally and full, just like a broadcast camera system, and you can set that all up via just HDMI cables for a small mini production studio type application. The Pocket camera is available both in a 4K version, which is a micro four thirds lens mount, and also a 6K version, which is an EF mount 6K chipset. So those are just some of the different tools that you could use for basically for live streaming. Now, again, if you own one of the newer Canon cameras, a Canon DSLR, or even some of their portable cameras like their M50 and things like that, some of their compact cameras, some of their more recent cameras that have a USB jack, Canon has actually come out with a new driver that you can load into your computer. And so when you load that on your computer, you can now capture directly from the Canon camera via USB directly in. So basically your camera just shows up as being just like your external webcam would be, but now you're using your nicer camera with your nicer lenses, and you can get a much better quality. So again, that's all about those kinds of things. This is another lighting system that's behind me that's coming in June. This thing's got 2 different lights built into it. I'll turn it on for just a second. You can see, so it's got 2 lights built in it. Again, it's for home style studio applications. And then it comes with this little clip, so you can put in your phone. So I can put my phone up in here and put my phone in and basically do self-recording and whatnot right into the system and do my own little live stream production right off of my phone with that type of device. It's fully bicolor with preset color temperature settings and whatnot, and each left and right are individually adjustable. So again, you can create some nice lighting effect with key and fill and whatnot with that light. I think I did forget to talk about these other lights. If you're looking for something with more power or more oomph, there are these lights called Forza Lights, and they're fairly new. They were launched just late last fall and have been just starting to ship through the winter. This one is a 300 watt light. There is a bigger brother to this, which is also a 500. So this is a daylight only output with a cob type chip on the front of it. And this light at 300 watts will push out more light output than an M8 Airy HMI type light, and the 500 will put out almost what an M12 will. And there's a smaller baby brother of that, which is a 60 watt version, so roughly around equivalent to about a 600 watt fixture of tungsten. And so this is kind of equates to kind of the old redhead type kit light that we used to have, although it's daylight balanced now instead of tungsten. Again, most of the cameras today are optimized for daylight anyway. Most of the sensors are. So this comes also in a 2 and a 3 light kit, very affordable kit light type package. So a lot of those kinds of things. And I still have a few minutes left. Good. So the next thing I wanted to talk about was Zcam. So Zcam is a new camera company. It's been around for about only, well, I guess they've been around about 3 years. Primarily, they did virtual VR type cameras previously, and then about 1.5 years ago, they introduced their first kind of production or cinema camera, which was called the E2, which is this the one up here on the right. The E2 is a micro four thirds kind of block cam. Very it's made of basically a block of cast aluminum. There's no fans or anything in there. The aluminum acts as the heat sink for the camera. And then after that, they introduced a much more affordable baby brother of that camera. And then just last fall, they introduced what they call the flagship series. So again, the E2C and the E2 are both micro four thirds inch mounts. And then they introduced the flagship series, which all had EF mounts as standard, but you can also switch out the mount for a very affordable mount for PL, micro four thirds, and there's talk of a third-party E-mount coming in the future, whatever. So you'll be able to put all types of different types of glass onto these cameras. So again, the chip sizes in here are Super 35 in the S6, a full-frame 6K chip in the F6, and a full-frame 8K chip in the F8. All these cameras are very super affordable, sub $10,000 kind of level. So I'm just going to go back over here now. And basically, so what I have here kind of set up is an E2 that can be set up in sort of, this is set up in a production mode with a small monitor on the front of it. This is a micro four thirds, so I just have my micro four thirds lens that I borrowed off of my Olympus SLR. And then I have a little audio pack in here that allows me to convert XLR audio into the mini jack into the side of the camera. Records on CFast cards internally, or I can have an external SSD. But another cool thing about this camera is it has a little USB-C port on the back of it here. And with this USB-C to Lightning adapter, I can plug in that into my phone, and then I can call up an app on my phone that I have full remote control of the camera. And I can actually see the video off of the camera on the app itself. And in the app, I can actually live stream if I want right directly off of the camera. So that's one way I could live stream with this camera directly in location in the field. Another thing I can do with this camera is you might be able to see here on the E2, there is a LAN port on the back. So this LAN port is available with all of the Zcam cameras. All 5 models have a standard LAN port interface connection. And so that LAN port actually outputs H.2.64. And then when we bring that into the computer, basically what I've done here is I've run through a switch first, so I could actually hook up a couple different cameras, wired, Cat6, over IP, bringing in that H.2.64 video. And then I can flip that video in the computer using an app called Stream Converter, which is a free app from Zcam. It allows you to see those cameras and flip those cameras into NDI. And so again, once it's in an NDI form factor inside of the computer, with a plugin from OBS, I can see that camera, see one of those cameras directly in OBS with that free plugin. Or I could see them in another application. So if I ran over here, this application here is called vMix. And so in vMix, you can see that I'm actually bringing this camera in across the network into my computer. It's not coming in through the ATEM. It is also wired in HDMI. That's why you can see the same camera when it's coming through the ATEM. But in this instance, in this program, it's actually coming in through the NDI, through the Stream Converter interface. And as I said, you can do that with multiple cameras and have them all come back in. And with the latest version of Stream Converter, because the cameras are also 4K capable, if you have a powerful enough computer, which mine is not, the one I have here, that can do full 4K processing, within the Stream Converter application, you can also do a region of interest. So you could, with a single camera, actually create 4 virtual camera shots and process them all out to HD cameras so I could have a wide shot, a medium shot, a close up, all kind of cut out of the same 4K picture with that software and being fed here as 4 different camera sources. And then I know I'm starting to get really close to time. I have one last thing I was going to do, and that is I was going to run this little application on my phone, and I'm hoping that this will actually show up. Hoping. And of course, it worked in all of my tests previous to doing it here. But anyway, because I'm near time, basically I can run this little NDI application in my phone, and then also run the camera app in my phone. And then that camera app will be seen over wireless because I'm connected in this house on the same wireless network system as I have running the switch and everything else off of. I could bring my phone in. So if you were doing something like a small concert in a small venue or something, and you wanted to have people in the audience or whatnot, they could actually be feeding back live shots to this vMix software, and you could be using the vMix software to do your whole program with these cameras all connected as NDI over IP, which means that they can be obviously miles away over network and can all be connected. So I think that's about it for my time. I think if there was any questions or anything, I'd be happy to answer.
Yeah, I think what we're going to do is we'll hand this over to the question side, and we'll let Jordan and Greg take it with the questions that have started coming in.
Great, thanks, Tony. I'll just monitor the chat here.
Everybody's using OBS. Is everybody making money using OBS? Like, is there much more demand for it? Are they teaching it in schools now?
So I think this is a question for Brian. Is that right, Anthony, or are you just making a general comment?
I'm just making a general question, you know, like I tried to pass it off to Francois today earlier. Craig, you know, you've dabbled with it a little bit.
Yes.
You know, I was using it for my presentation, and you know, we just had a presentation there where it was being used. Is it like the norm now, or are these other softwares like vMix becoming the norm?
Sorry, I didn't hear that. What was the question again?
like are a lot of your customers looking for OBS type solutions?
I think that there's a range of customers that are looking to get started anywhere from free. Many customers are looking for solutions that they can have a little bit more reliability with. So what I find is the chargeable version of vMix, the stability is a little bit more there, and works a little bit more like a traditional kind of switcher would. It has that kind of mindset, where OBS kind of has this mindset of scenes and sources and creating scenes, which for some people from a broadcast perspective have a little bit more trouble grasping. So again, it depends on the type of the operator who's using the software and what their hope is to try and have stability. So within the vMix family, there are, you know, a range of price points from an entry-level HD option all the way up to a high-end full pro level option with fully featured with multiple NDI sources and whatnot. So there's a full range or a full bouquet of choices to make those connections. We're typically, I mean, even in my own experience using OBS, I find that it can crash on you. A lot of sources were working, and then I'll come back to them again, and they're no longer working, and things like that. And there's a lot of things that are still a little bit buggy, I think.
Yeah, I have a comment here from a Brad Dinkinson, and he was saying that he's using vMix as opposed to OBS. And also Gord mentioned that Telestream has a product called Webcast Gear that also is available.
Yeah. There is a number of different chargeable pieces of software that are available out there from different vendors, and so again, it's the difference between, I think, getting freeware and getting something that's a little bit more stable and is a little bit more of a professional tool.
So going to Francois' point, and hardware and fast hardware and FPGAs being the way to go, are there things that are not computer based that can't do the same type of streaming? So like a Teradek, is it Teradek that makes that?
So Teradek and whatnot are external streaming boxes. So those are basically like a standalone hardware streaming boxes, and we also have a bunch of those. I mean, I only had 20 minutes. If I was here for the entire 2 hours, I could maybe go through our whole repertoire of live streaming solutions, and certainly Teradek is one of them. And there's a couple other boxes from other vendors that do the same type of job. Datovidia has one, and a few other different companies. So Matrox, a few others make hardware encoders. Typically, those encoders, again, they're designed to simplify things so that the operator maybe doesn't have to deal with the software interface part of it. They're basically plug and play, and they just work. And so, again, they make it easier if what you're doing is maybe putting in a single source or just using a small external switcher to switch a couple of sources. Then those standalone boxes means that you just press a button for live stream. A lot of people like doing it in the software on their computer, because when you're doing a live stream in the software on your computer, you can do more of your computer resources. So if you wanted to share a screen that was on your computer, or if you wanted to play a video file or an audio file or a picture or a graphic or something like that off of your computer, or even if you wanted to have a fallback bubble slide, or we'll be on air in 10 minutes or whatever, all of that could be built in OBS or in the vMix software. You can also integrate graphics and have all of those available. Some external switchers, like the Blackmagic ATEM, allow you to have graphics, but basically you've built the graphics, pre-built them in your computer and pushed them over to the switcher. And now they're basically resident in a memory. They're basically just pictures at that point in the switcher, and you can either downstream key them if they're lower thirds, or you can just bring them up as a full image. So it's all about workflow, and again, it's all about mindset of the operator. Is how tactile is the operator. A lot of people like buttons. A lot of people don't like mouse clicks. A lot of people like mouse clicks. A lot of people like GUIs. That's what they're more into. So it really depends on how you want to shape the system and make it work, again, most effectively for you. It's easy for the operator to operate, to walk up to the system and be able to do what he wants.
Why is audio so hard? And on behalf of the Audio Engineering Society, thank you for making audio so hard.
I think audio is hard until you understand that it can be simple. So again, with a lot of these, there's a lot of audio interfaces. I didn't even talk about any of those. So there's certainly dozens and dozens of different audio interfaces, which will just allow you to convert a microphone or the audio from a full mixing board and bring it in across the USB interface. And I mean, those will bring in full 20 to 20 hertz and whatever, 20 to 20K hertz. So, the sound quality can actually be quite good and be very easy to plug and play through that USB interface. And then again, depending on the software, there's a few clicks that you have to press to make sure that you've got the right source routed to the right thing. That's like part of my thing for even doing this tonight, because I'm trying to run OBS and also the ATEM software, and also vMix, and have all of that, and certain sources are consumed by all those different applications all running simultaneously on my computer, and then still trying to do webcams and everything else, and then run this and go to meeting. It's something that definitely you want to run some tests. We do live streams. We've started now a couple times a week where we typically do it through OBS, and then we're bringing in calls via Skype, because we've found Skype to be easy for most people, simple interface for most of the guests. Skype has just been the easier thing.
How has delivery been with COVID?
Delivery of product? Well, certainly the ATEM minis are back ordered.
Till?
So, I mean, we've been open on the web through the whole COVID thing. We've instituted a lot of new things like online chat on the web, and we've actually upgraded our whole phone system and whatnot so that we could do more support remotely, better quality for the remote operators. So basically, our sales have been strong. I would say our business has changed somewhat, has shifted. I mean, I guess a lot of it's more live production oriented, where people are looking for these types of solutions. But our business has been strong. And vendors, I mean, certain things like webcams are hard to find. Obviously, you can go almost any website, you're going to be hard pressed to find a webcam today. But I think as this goes on, that all the vendors are gearing up. Like I know from say Blackmagic, they're now running double shifts. Every one of their factory workers gets driven in by a limousine in the morning to work now to be able to work, because they're trying to all gear up for supply.
So Brian, also, I turned on Brad Dickinson's mic if he wants to ask a couple questions to you, if he's still there.
Yeah, I know. Yeah. Brad has an E2C, I think.
That's right. What I was going to note was the E2C has the unique ability to be PoE. So basically, if you have a PoE switch, that's your whole distribution. That's your power and distribution of audio and video through the E2C. Another note too, with regards to vMix, it also supports not just NDI, but also SRT.
Mm-hmm. Yeah, having that power PoE is excellent, and definitely for the E2C. And we're getting a lot of houses of worship and a lot of other, smaller broadcast applications where people are looking at that camera, because again, it's so affordable and easy to connect and whatnot for those types of applications. So we're getting a lot of inquiries over that. And certainly even the 8K version, unfortunately the summer's Olympics were canceled, but that was one of the main cameras that they were going to have deployed at a lot of the sporting events at the Olympics, was the 8K camera, and they were going to be doing 8K streaming back from that camera. So that was part of the plan.
The other thing that the Zcam software allows you to do is monitor the video coming in, but it also allows you to color correct the camera. So you can actually have a little bit of CCU control via your computer on the Zcam. So you can adjust some of you can't just hue, but you can just tint, you can just vary the color temperature. You can see just a lot of color controls. You can actually do a little bit of color matching of your cameras a little bit.
Yeah, I mean, you can control through that stream converter software. You have full remote control of most of the menu settings of the camera.
Yep. All right, thanks, Brian.
And that can be done in a direct mode as well. So similar to having the app on your phone, you can your phone could be wirelessly connected to the camera just for control. There's a little bit more latency in the video. If you connect it with that USB-C cable, your latency is reduced. And then you can actually do the live streaming via your phone by having that hard connection, because then you can connect to the external source and not consume your Wi-Fi that's connecting to the camera. And then if you're want, you can use the LAN port and can just direct control remotely via computer. So again, if you're on set or something and you're trying to adjust camera settings or whatever from the director's pit area, you can be able to just set all that up and control the camera and change the shading or add a different LUT or any of those kinds of things that you wanted to do.
Okay, cool. I think we're done for questions at this point.
Okay.
Tony, do you want to give your last comments?
Yeah,
Sorry to cut
you know,
guys off.
I will.
I don't want to be everybody here all night though. So
I'll take it from here. And
you,
the thing is, if you still have some questions, and just shoot us an email, and then we'll make sure we get it to the right appropriate person, and they can contact you directly.
Yeah, one of the things too, if you wanted to, again, I'm set up here, you wanted to talk individually about any of these, you had interest in any of these products, or you need help, we're doing a lot of this through collaboration software. We're actually doing live product demos now. So if I have the product here or whatever, I can show you what I'm doing.
Good, thanks, Brian. So let me just, I've got a couple of slides here I'd like to go through. So you know, Montreal is doing their boot camp. It is going to be online streaming. It's a full day event, and its topics are going to be esports and remote productions. So for more information, the Montreal website would be a good place, and I believe that is the link to register. But I just saw that email come through, but do check out their website first before or you can go to the Eventbrite to see whether or not it's live for ticket taking. On our next meeting, which will again be a go-to meeting, I think tonight's looked and worked really well. I hope you guys think the same. The topic is going to be 5G technology. We've got some 4 presenters from Vidcom, Highway, Bell, and also MediaKind. So there are 4 topics, 10 things to make 5G different, and architecture, when will it come, and how will it affect, or how will it be used in the industry. And again, it's still fluid. We're still moving. The date has been locked. It is June the 9th. It will be at the same time, 7 o'clock. And stay tuned to our SMPTE website for additional information. And once we get the notice ready for release, we'll be sending out a mass email to everybody. For the SMPTE members that are still with us on this meeting, do remember that the election process is on, and it closes June the 1st. So if you haven't voted for the various people that are running in various sections, please do so. Tomorrow and I believe Thursday, there is NEB Express, which is the scaled down version of the NEB show, the papers portion of it, and some of the broadcasts. It is free registration, so all you need to do is register. Also, SMPTE has mentioned that for the next little while, and I'm not sure what little while is, 17 standards are free. So the core 2110, 2059, MXF, and 12M timecode is, these standards are all free for the asking. This meeting was recorded, and once it is converted, we will put it up on our YouTube channel. And again, to stay in tune with us, these are our social links. And if you're not a member of our section or of SMPTE home office, we do have a Become a Friend program. So if you go to the Toronto section over on the right tab, there is a Become a Friend portal that will allow us to send you emails, and those emails will be all of the various meetings that we will have that are happening locally in Toronto. So I believe that is it. And I thank everybody. I thank Craig and Jordan for arranging this meeting, and I thank our presenters for spending time with us. It was a great meeting and lots of information, and thank you very much. And thanks to all for joining us. So that is it for the formal part of the meeting. Thanks very much, and we will see you June the 9th, hopefully. Bye-bye.